All right, so in this video, we're going to look at logic gates and circuits. So there's three primary operators when we're talking about Boolean logic gates. And these are not, and or. So not, when it's used by itself, is used in this form with a triangle followed by a dot on the end and a little circle. And looks like, honestly, it looks like a plug to me. And it has this rounded shape, kind of like a D. And then the or operator reminds me so much of a sidewise Star Trek emblem, but that's what the or operator looks like. Now, you can combine these together. You will often see examples of negations being added on top of operations by just adding this dot on them rather than the full triangle and then the not, the little circle. But we'll go through and we'll look at these examples. Now, basically, we're looking at outputs into the inputs and outputs into these gates that have true or false values. So you can see that the not operator takes only one object. So it's either true or false, and then the not operator flips that truth value. The and operator takes two inputs, true or false. And if they're both true, it comes out true. If any of them is false, they come out false. And then the or operator, it takes two inputs. If both of them are true, it comes out true. If either one of them are true, it comes out true. If they are both false, it comes out false. Now we can look at some examples. So for instance, we can have these complicated circuits. Sometimes they'll be represented by multiplication for and, because if you replace 1 and 0 for true and false, then and requires that you multiply. So if they're both 1, you get 1, but if they're either one of them is 0, you get 0. The or will do addition in the sense that either of these being 1 will count as a true statement, but if you get 2, then it still counts as true. You can use combinations. So as I noted above, you will sometimes see that negation operator tacked on without the triangle just to the nose of another operation. So here you will first take the and then you will negate it. So sometimes this is called a NAND operator. It's not and. So first you and it, and then you flip the truth value. So if both of these are true, you would get a 1, and then therefore not that would be the negation. So a value of AB equal 1 would become 0. But if AB was equal to 0, flipping that truth value would make it a 1. So it'll be true if both of them are if either one of them are false or if both of them are false. And it'll be false if both of them are true. And then the NOR operator works similarly. Again, it looks like just this little circle on top of the OR operator, and you take the OR operation and then you apply the negation to the result. So OR is true if either of these are true or both are true, and false if they're both false. This one will be true if they're both false, and false if either of them are true. There are also variations on, okay, this is the not operator by itself, and there are also variations on the or operator for exclusive versus inclusive or. So or by itself is generally considered inclusive, which is to say that both can be true and it's the or operator will still be true. In the exclusive or case, you have this extra line down here to remind you that it's an or, but it's a little bit different. And this just means that if one of these is true, exactly one of these is true, then it will be true. But if both are false or both are true, then you will get false. So it's like really an either or option, not both and. And then exclusive NOR, again, this would be true if both are true or both are false, but false if only one of them is true. The reverse of the regular exclusive or. Now, most of the time, you're only going to be working with potentially the and, or, and maybe the nor and and cases. Exclusive or is sort of an extension of the regular or operator, and you may see many examples where they don't use it at all. So let's look at some examples for how this works. So here is our AND circuit with the not on the end. So this is our NAND. So if I have an input of true and an input of false for my A and B values, then this will go through. This is equivalent to not A and B. And the AND operator will be false since one of these is false. And therefore the NAND operator will come out as true because and is false and the not flips the value to make it true. Another example where we can label the results of our true-false operations directly on our circuit. So here we're specifying A and C are true and B is false. So here for this circuit, B and C are going directly into this AND operator. And so since one of them is true and one of them is false, you're getting false. Now, this B function is now going through a not operator. So it's turning it into true, and then it's swinging back around, and not B and A are going into this AND operator. And since this negated the false B and made it true, we have true and true going into this AND operator. So it comes out as true. And then we have the result of this and the result of this and going into this or operator, which now, because one of them is true, comes out as true. So the value of our complete statement, D, is true. And then here's another example that produces, again, a compound statement. We have inputs X, Y, A, B, C, D, and Z, which is a lot, but we take them essentially two at a time. So here, X and Y, this is going into an OR operator. One is true and one is false, and so that produces a true. B and C are both true, and they're going into this OR operator. That comes out as a true. And then that result is combined with D, which is also true, which goes into this other OR operator. True and true produces a true. And then this result is combined with A, which is false, and goes into this AND operator, which is also false. The result from up here, true, goes in together with this false into another AND operator, which produces a false. And then this false is combined with this false from Z, which has never been used before. And we have two falses going into this OR operator, which produce statement F, which is a false. And we can rewrite this compound statement this way, which is extremely messy. But the circuit allows us to go through and evaluate the symbols very carefully and very visually, rather than in this kind of crazy complex statement.